This is Chemistry 108, Chemical Principles 1 at York College. Today is February 5th, 2015, and we're continuing in Chapter 1. So last time we started looking at dimensional analysis, how to do calculations. And the one of the important uses of dimensional analysis is the conversion of units, to move from one system of units or one type of unit to another type of unit. And so we can do this between things like centimeters and inches. We can do this between meters and centimeters, all sorts of different units, whatever types of units that measure the same property of matter. Here we're looking at length. Whatever kind of units measure the same property of matter, we can convert them as long as we have an equivalence or a conversion factor. And so let's learn by doing. That's really the best way to learn. This time I brought chalk, my own chalk and my own eraser. So here we have some conversion factors. There's 100 centimeters in a meter, and you know that because you've been learning the prefixes in the metric system like I told you last time, right? Good. That wasn't very enthusiastic. So you will be learning the prefixes in the metric system like I told you last time. And there's 2.54 centimeters in an inch. We also kind of finished up there last time. So let's do this. How many inches are in 1 meter? Actually, before we do that, let's take a step back and review, right? So let's do a pre-problem before this problem. Let's do this. How many meters are equal to 273 centimeters? Anybody have an idea how to set this up? Yes, Mr. J.
1 meter over 100 centimeters.
Okay, so he's setting up a conversion factor. So he's saying 1 meter equals 100 centimeters, right? So you said 1 meter over 100 centimeters. Now what?
Is equal to x over 273 centimeters.
That's not bad. That's not bad, but that's not the way I want to do it. Yes, sir. I can't see your card, but that's okay.
273 centimeters.
Yes.
Multiplied by 1 over 100 centimeters.
273 centimeters. Multiplied by 1 meter over 100 centimeters. Right. If I want, remember, if I put anything over 1, its value stays the same. So if it helps you, you can put this over 1. You don't have to. But this shows you numerator, denominator, numerator, denominator. And when I multiply with numerator and denominator like that, I brought colors this time. I'm so excited. What happens? The centimeters and the centimeters can cancel out. And what's left in terms of units? What's left in terms of units is meters. So when I do this calculation, maybe I haven't done the math yet, but my unit is going to be meters. And what's my number? Remember, we have numbers and units. What's the number going to be? It's going to be, yeah, so it's going to be 273 divided by 100, and that's going to give me 2.73 meters. Any questions here? Okay, so let's move on to this problem over here. It says, how many inches are in 1 meter? How can we approach this one? Do we have a conversion factor that gets us between inches and meters? Sorry? 100 centimeters equals 1 meter. That's correct. But that doesn't get me from inches to meters. That gets me from centimeters to meters.
Maybe you could convert it from centimeters to inches.
Okay, so let's convert first from centimeters to inches. That's the right thought, but we don't know how many centimeters we have, right? Yep.
Can you do from meter to centimeter and centimeter to inch?
Right, right. So you had the right idea, just kind of a little backwards. So meters to centimeters, then centimeters to inches. So we can do them sequentially, one at a time. So I'm going to start with what I know. I know 1 meter. And I'm going to and then I'm going to leave a space for my conversion factor. What goes here? I want to get from meters to centimeters.
Shouldn't the meter be in the bottom so you cross it out?
Right, so the meter is going to be on the bottom. This 1 meter is this 1 meter, not the conversion factor. Right, here's the conversion factor. 1 meter equals 100 centimeters. And I can cross out my meters and my meters. I don't know what the answer is yet, but I know it's going to be centimeters. Yes?
Then it should be the open parentheses again and put centimeters at the bottom and inches at the top.
Centimeters at the bottom, inches at the top. And I'm going to read off the numbers from here. 1 inch, an inch, equals 2.54 centimeters. 1 inch equals 2.54 centimeters. Centimeters and centimeters cancel. What's left? Inches. So I haven't done the math yet, but I know the answer is going to be in inches. And when I do the math, it's 1 times 100 divided by 2.54. Right, and I happen to have done this calculation beforehand, and I get 39.4 inches. Okay, so when you're multiplying fractions, right, we can pretend that this is over 1, right, because it has no denominator, but the denominator is 1. So what do? We multiply everything on the top, and we divide by whatever's on the bottom, right? So 1 times 100 times 1, right? So basically just 100 divided by 1, divided by 2.54. So essentially it's just 100 divided by 2.54, which, if I did my calculation right, gives me 39.4 inches. Questions? Should we try another one? Yes, wonderful. So, let's work with the metric system. We have $300,327 for milligrams. Okay? And I want to convert that to kilograms. Now, from the table that we looked at last time, and that's in your book, we know a conversion factor between milligrams and grams, and a conversion between grams and kilograms. What we don't know is a direct conversion between milligrams and kilograms. So what can we do? We can go first from milligrams to grams. That's a horrible G. Milligrams to grams. And then from grams over to kilograms. Can somebody tell me what the conversion factors are, or what the equivalencies are?
100 milligrams is equal to 1 gram.
Say that again?
100 milligrams is equal to 1 gram.
Not quite.
1,000 milligrams to
1,000 milligrams equals 1 gram. So I'm going to try to stick to what the way the table puts it. So 1 milligram equals 1 times 10 to the negative third grams. And 1 kilogram equals 1 times 10 to the positive third grams. So can somebody tell me what I'm going to do now? And I see your cards, so I'm going to call on somebody if I don't hear. Yes?
Can't you just move the decimal 3 times?
We can move decimals, but we're not going to, at least not until we set it up. Because maybe you can do this just by looking at it, but you won't be able to do everything just by looking at it. So we're going to learn the setup first. So you're not wrong, but I want to do it the way I want to do it. Yes, Mr. J.
What if you do,
Agent J. Sorry.
what if you do 3,274 and convert it to a scientific notation? So you're making to a decimal, it's like 3.274.
Okay, we can do that. We don't have to, but we can. So 3.274 times 10 to
0.3.
not quite. Negative means it's less than 1. Right, times 10 to the positive 3. Right? Because what's 10 to the third? 10 times 10 times 10 is 1,000. Right? So, okay, we don't have to do that, but we can do it. So, milligrams. And so, now what? Yeah.
1 gram over 1,000 milligrams, and then 1,000 kilograms over 1 gram.
Okay, so right, so we'll get back to that. I want to use this one. Right, this is also another way of looking at milligrams. This is what you learned in your table. So we're going to have, but the point is milligrams in the bottom, right? Why do I know that milligrams are in the bottom? So that you can cancel them. So milligrams in the bottom. So 1 milligram equals 1 times 10 to the negative third grams. And what's going to cancel? What's going to cancel is milligrams and milligrams. Now I'm at grams. What comes next? What's at the bottom? Grams at the bottom. Kilograms on top. How many? So 1 kilogram equals 1 times 10 to the third, or 1,000 grams. And so if I put that all together, I'm going to cancel my grams and my grams, and what's left is kilograms. So what's left is going to be kilograms. And I like the fact that Agent J converted this to scientific notation. That means I can do this in my head. Maybe you don't know how to do it in your head. That's okay at this point. So it's going to be 3.274 times 10 to the negative third. I ran out of space. .274 times 10 to the negative third kilograms. If you did it all on your calculator, you might have gotten 1, 2, 1, 2, 3, 2, 7, 4 kilograms.
How do you get to have -3 and positive 3's cancel out?
Okay, correct. So when you're multiplying with scientific notation, you add the exponents. Right? When you divide, you subtract. Right? So what I'm doing is multiplying these two. So I'm adding 3 and negative 3. When I add 3 and negative 3, I get 0. So now I have 0, and I'm subtracting 3. So 0 minus 3 gives me negative 3. You could also look at it as 3 cancels out with 3, and you're left with negative 3, but that won't always happen. Okay. Lots more fun we can have, but we'll do one more before we'll do plenty more, but we'll do one more of this type over here. And so let's go from five point 0.08 meters, no, kilometers over 2 centimeters. And we're going to do it like this. We're not going to do it on the board. What I want you to do is find 1 or 2 or 3 friends and try it. See if you can set it up together and put your heads together gently and try it. Okay. Yes. What's your question? We haven't gotten to significant figures yet, but yeah. Okay, so Miss Whatever told us that. So now this is when you stop talking to your group. That 1 km, 1 kilometer, equals 1,000 meters. And 1 meter equals 100 centimeters. So basically what we're doing is what we did above. We're going through the primary unit, right? So we're going from kilometers to meters. We know that. And we're going then from meters to centimeters. Where do we start? We start with what we know. We have 5.0 km. The first conversion gets us from km over to meters. Right? The second conversion gets us from meters over to centimeters. So then we get 5.08 times 1,000 times 100, and that's going to give us 508,000, or 5.08 times 10 to the 1, 2, 3, 4, 5. 5.08 times 10 to the 5 centimeters. Questions?
Can we do the other way with the scientific notation?
Yeah. I mean, if you do it with scientific notation, you're going to get, okay, so this is 5.08 times 10 to the 0, right? Because 5.08, 10 to the 0, what's 10 to the 0, by the way? 1, right? So this is 5.08 times 1, which is 5.08 km. 1 km. Km is going to go in the bottom, right? Because we want the km and the km to cancel. Equals 1 times 10 to the 3rd meters. Km and km cancel, we have meters. Then meters and centimeters. The way that your book sets it up in the table is always 1 of whatever these are. So 1 centimeter equals 1 times 10 to the negative 2 meter. Right, this is written meters in terms of centimeters. This is written centimeters in terms of meters. It will give you the exact same answer. And so if we do it with the scientific notation, 0 plus 3 is 3. 3 minus negative 2. Minus negative 2, 5. Right, so that's going to give us 5.08 times 10 to the positive 5th centimeters, and these two are equivalent.
Wait, how'd you get positive?
Okay, so remember, on the top we add the exponent. On the bottom we subtract. Right, so 0 plus 3 is 3. Then 3 minus negative 2. Right, so 3 minus negative 2 is the same as 3 plus 2, which gives me 5. Okay, so some of you know how to convert the metric system from somewhere in the past. That's okay if you get it right. And for these, it's okay, right? If you count, if you count a certain way, then you can move the decimal point and so on. If you get it right, it's okay. But I much prefer you to set it up this way, because what we're going to do next, and what we do many chapters down the road, for many chapters down the road, isn't going to work quite so easily. So you might as well get used to it, right? So that's kind of the point I have here. So let's try this one. Remember volumes? So volumes can be measured in liters and milliliters and so on, but they can also be measured in cubic centimeters, right? Centimeters cubed. And so let's do this over here. 227 centimeters cubed over 2 meters cubed. This is a little bit less straightforward. And what we need to remember here is that units behave like numbers. So if I'm looking at centimeters cubed, what does that actually mean? Centimeters times centimeters times centimeters. So if I want to convert centimeters cubed to meters cubed, what am I trying to go to? I'm trying to go to meters times meters times meters. I know a conversion factor between centimeters and meters, but I have to do that. I have to convert this one, and then this one, and then this one. So I need to do it 3 times because of the cube. Convert centimeters to meters, centimeters to meters, centimeters to meters. How am I going to do that? 200 and, can you see that? 227 centimeters cubed so it's 1 meter equals 100 centimeters. Let's see, we can use that one. I'm going to do this. 227 centimeters cubed is 227 what? Centimeters times centimeters times centimeters. And so in order to convert, what I'm going to need to do is, what's on the bottom? Centimeters. What's on the top? Meters. 100 centimeters equals 1 meter. What is that going to do? That's going to get me, am I done? No, I need to do it again. 1 meter, 100 centimeters. Am I done? No, one more time. 1 meter, 100 centimeters. Am I done? Yeah, except for the calculation, I'm done, yes. So, and what I'm going to get when I do this out is 2.27 times 10 to the negative fourth meters times meters times meters. Meters cubed. Meters. Okay, where did I get the negative 4? This is 2.27 times 10 squared. 2, right? 1, 2. This is, each one of these is 1 times 10 to the 2. 1 times 10 to the 2. 1 times 10 to the 2. So positive 2. Minus 2, because it's in the denominator. 2 minus 2 is 0. Minus another 2 is negative 2. Minus another 2 is negative 4. Right. So 2.24 times 10 to the negative fourth meter cubed. I could also set it up like this. If I wanted to be a little bit more compact, I'll change colors here. 227 centimeters cubed times 1 meter over 100 centimeters cubed on the whole thing, right? Cubed on the whole thing means 1, 2, 3. I need to remember not just to write it cubed, but to actually cube it, right? So this is going to be, I'm going to cube this on my calculator. I'm going to get, or in my head, 1, 2, 1, 2, 1, 2. A million. And that's going to get me the same answer. 2.27 times 10 to the negative fourth meters cubed. Right. If you don't write it out like this, that's okay, but you need to remember not just to do 227 divided by 100. You need to do the cube before you do the division. Questions here? Sorry? Okay. Let's try this now. let's try to put some concepts together. Now we're looking at squares, not cubes. If we're looking at squares, what are we going to do? Squares, these are areas, right? If we're looking at squares, how's it going to be different than cubes? Yeah, we're going to use it twice instead of 3 times. Oh, but wait, I'm going from millimeters to centimeters. So what do I need to do in terms of the conversion? Do I know a conversion factor to go from millimeters to centimeters? I mean, you might be able to figure it out, but off the top of, from our chart or whatever, no, we don't. So what am I going to do first? Millimeters to meters, or millimeters squared to meters squared, and then meters squared to centimeters squared. Let's do it together. Should we do it together? Okay. You're going to have to do these by yourself eventually. What's the conversion from millimeters to meters? So we have 1 millimeter, I'm going to do it this way, equals 1 times 10 to the negative third meters. You can do 1,000 if you want. 1,000 millimeters is 1 meter, if that makes you happy. And then 1 centimeter equals 1 times 10 to the negative 2 meters. That's the erasing doesn't really work so well. I'm going to use one of these kind of darker color things here. Okay, so where do I start? Yes, sir.
Doesn't that mean that 100 millimeters is equal to 1 centimeter?
Not quite. Not 100. The difference between this and this is just 1 power of 10. So it's actually 10. If you can work that, you can work that, but you don't need to, right? It's because we can do it. We can do it this way. So we start with 3,477 millimeters squared.
Can't you do 3.477 times 10 to the third?
Yes, we can. Let's do that. Just because the more scientific notation you work with, kind of the better. So 3.477 times 10 to the third millimeters squared. Now what do I want to do? I want to go from millimeters squared first to meters squared. So the conversion here is, what goes on the bottom? Again, sorry? Millimeters. And what goes on the top? Meters. And so I can say 1 millimeter equals 1 times 10 to the negative third meter. And for now, I'm going to write it all out. 1 millimeter equals 1 times 10 to the negative third meter. Remember, there's 2 millimeters here, right? There's not 2 millimeters. There's millimeters times millimeters here. So now I'm at meters squared. Now I want to go from meters squared to centimeters squared. What goes here? On the bottom? Meters. And what goes on the top? Centimeters, meters, centimeters. And so I get 1 centimeter equals 1 times 10 to the negative 2 meters. 1 centimeter equals 1 times 10 to the negative 2 meters. And because I know my scientific notation, right, 3 minus 3 is 0, minus another 3 is negative 3. Negative 3 minus a negative 2 is negative 3 plus 2, that's 1, plus 2, a negative 1, and then that's 1. So that's going to give me 3.477 times 10 to the 1 What's the unit that I have? Centimeters times centimeters. Centimeters squared. 3.477 times 10 to the 1 centimeters squared. Questions?
Does that mean it just stays the same since it's 10 to the first power? Or
10 to the first power is what?
Okay.
Not quite. It's 10 times nothing, right? It's 10. So it's 10 to the 0 is 1, right? Anything to the 0 is 1. 10 to the 1 is 10. So this is going to be 34.77. 3.477 times 10, 34.77. Okay, let's do one more. $57 meters per second. What kind of unit is meters per second? It's distance over time. So what are you measuring? What kind of quantity? What kind of property? Speed. Right, so distance over time is a speed. We're more used to things like miles per hour, right? Distance divided by a time. So let's meters per second over 2 kilometers per minute. Don't be scared. Same thing. Except now, instead of multiplying, you have a division. But we know how to use fractions. We know how to cancel units. And we know how to use conversion factors. So, what are the conversion factors we're going to use? 1 km equals 1,000 meters, right? Or 1 times 10 to the third meters. And then I'm going to change this number just a little bit. Let's change it from 57 to something that I can use handle a little easier. Let's say 180 meters per second. Okay? So 1 kilometer equals 1 times 10 to the third meters. What about seconds and minutes? 1 minute equals 60 seconds. Anybody want to tell me where to start? I'll give you a hint. Where you start is the easiest part. Yes, Mr. Carbon.
You could start off by having 1.80 times 10 to the second.
Okay, sure. We want to do it in scientific notation. I'm happy with that. We don't have to.
Meters over a second.
Let's just leave it without scientific notation now. Okay, 180 meters per second. That's a good place to start.
Times, I guess you wanted as 10 to the 1 times 10 to the negative 3 kilometers over meter.
Okay, so we can either convert. So what do we need to do? We need to get meters to kilometers and seconds to minutes. So we can do either one first. Let's do meters to kilometers and 1 times 10 to the third and 1. When I do my canceling, what do I get? I get, if I stopped here, I would get kilometers per second. I don't want kilometers per second, I want kilometers per minute. So now I need to get rid of my seconds.
And then you just take the seconds per minute.
Where do I want to put the seconds over here? Top. because we've always been putting them on the bottom, but now seconds is already in the bottom. How do I get rid of something in the bottom? I put it on the top. So seconds. 60 seconds. So, and 1 minute, right? Okay, so I didn't do this beforehand, so 6. So what I have is 10800 on top and 1, 2, 3. So what I get is 10.8 for my number. And let's do the canceling. So we got our meters gone and our meters gone. We got our seconds gone and our seconds gone. What's left? km per minute. So it's 10.8 km per minute.
Would it also be 108,000 times 10 third?
Times 10 to the negative third, because it's in the bottom. 1, 2, 3, which is where I got my 10.8. Okay, so let's take a break.